Okay, here we have a person riding on the Gravitron. It's a big spinny circle there, being held up not by the floor. So that's a person right there, and the thing spins around and around. So if we look at the forces on the person, there's a normal force from the wall against the person's back, and the person has weight, and the person doesn't slide down the wall because there's static friction. So the net force on the person in the y must be 0. And in the x, the person is in uniform circular motion. And the net force towards the middle is just n here. And we're looking for a speed, so I'm going to use v squared over r for the acceleration instead of 4 pi squared r over delta t squared. Okay, so if we're looking for a safe speed at which the floor must be dropped, I'm going to frame it as finding the minimum speed. And that means that the static friction is at its maximum. As if I spin this thing really, really fast and the normal force is very big and the static friction force could potentially be very large. We only need it to be mg large, so I'm going to try to find the normal force, the velocity which causes the normal force, which gives me a static friction force which can just barely balance out the person's weight. So that tells me that mu sub s n is mg, n is mg over mu sub s, so mg over mu sub s equals mv squared over r. The m's cancel, so in terms of designing this ride, you don't have to worry about the mass of the person. That's a good thing. And so mnv is going to be root rg over mu sub s. And I told you can estimate whatever you need to here, so the mu sub s we need to estimate. I'm going to think of it like I'm a designer, and so I'm going to pick a purposefully small mu sub s so that I have a large margin for error. So I want like a safety threshold there. So my radius is 7.5 meters times g over, I'll use maybe 0.3, which is pretty small for mu sub s, so that should give me plenty of room to make sure that, whatever happens, my riders are okay and I don't get sued. So that tells me about 15.8 meters per second, so we're talking a little over 30 miles an hour, which is certainly a reasonable speed for this thing to go.